Assalamu alaikum. Welcome back to another video lecture for the subject of HCI. Now, in this week, we are going to discuss about the research methods which are indulged in the process of data gathering for your interface design and in general with respect to human-computer interaction. When you start to design a new interface, your goal is to design an interface that will meet the needs of the user better than the existing design, and that's what we are discussing throughout our videos. It's very rare that we design for tasks that users have never even performed before. We are almost always developing new ways to accomplish old tasks. Facebook, for example, was a new way to socialize and communicate with others. But the fundamental activities of socializing and communicating weren't new. Facebook just met those needs better, or at least met certain needs better depending on who you ask. In order to design interactions that are better than existing designs, it's important to take into consideration the user's needs at every stage of the design process. That's what this and the upcoming lecture videos will cover. We do not generally want to build creative novel interfaces just for the sake of creativity or novelty. We want novelty to have a purpose, and to achieve that purpose, it must be used with a strong understanding of the user's task. So in this video, we'll cover the design lifecycle as well as methods for gathering feedback and information from users at every stage of the cycle. However, before we get started on that, we need to set up some basic concepts we use throughout our discussion. We'll start by discussing user-centered design, and then we'll introduce the 4-stage design lifecycle. We'll discuss a few different general methods for pursuing the design lifecycle. Then finally, we'll discuss the two kinds of information or data that we gather, qualitative and quantitative. Now, user-centered design is design that considers the needs of the user throughout the entire design process. As far as we are concerned, that's pretty much just good design. But oftentimes, that isn't the way design is done. Design has often done to meet some functional specification of what the tool must technically be able to accomplish, instead of considering the real needs of the user. Or sometimes people will go through an entire design process believing they understand the needs of the user without ever really checking. User-centered design is about prioritizing the user's needs, while also recognizing that we don't know the user's needs. So we need to involve them at every stage of the process. Before we start, we need to examine the user's needs in depth, both by observing them and by asking them direct questions. After we start designing, we need to present our design alternatives and prototypes to the user to get the feedback. When we near a design that we like, we need to evaluate the quality of the design with real users. Having a good working knowledge of HCI principles helps us go through this more quickly. But we cannot design great interfaces just by applying guidelines and heuristics alone. We have to interact with our users, understand their needs, and involve them in the evaluation process. Now, the International Standards Organization has outlined 6 principles to follow when pursuing user-centered design. Number 1. The design based on explicit understanding of users, tasks, and environment. That means we must gather information about the users, the tasks they performed, and where they performed those tasks. We need to leverage that knowledge throughout the design process. Number 2. Users are involved throughout design and development. Involvement can take on many forms, from regularly participating with interviews and surveys about our designs to actually working on the design team alongside the designers themselves. Number 3. The design is driven and refined by user-centered evaluation. We must absolutely have real users evaluating the prototypes and interfaces that we assemble. Number 4. The process is iterative. No tool is developed once, released, and then abandoned. Designs undergo constant iteration and improvement even after being released. Number 5. The design addresses the whole user experience. Many designers are tempted to delineate a certain portion of the experience as their primary interest, but we must address the entire user experience. Number 6. The design team includes multidisciplinary skills and perspectives. Good teams for pursuing user-centered design include people with a number of different backgrounds like psychologists, designers, computer scientists, domain experts, and more. So keep these principles in mind when you are doing user experience design. When we talk about user-centered design, we throw around the word user as if it's pretty obvious what it means. The user is the person who uses the interface that we create, right? However, that's not the only person in whom we are interested. There are multiple stakeholders in this design, and we want to explore how our design is going to affect all of them. The user themselves is what we call the primary stakeholder. They are the person who uses our tool directly. Secondary stakeholders are people who don't use our system directly but who might interact with the output of it in some way. Tertiary stakeholders are people who never interact with the tool or even interact with its output, but who are nonetheless impacted by the existence of the tool. So let's take a couple of examples of this. Imagine we are designing a new gradebook tool that makes it easier for teachers to send progress reports to parents. Teachers would interact with the tool, inputting grades and feedback, and so teachers would be our primary stakeholders. Parents receive the output of that tool. Parents receive the progress report, and so they are secondary stakeholders. They interact with the output of the system, but not with the system itself. The students don't use the system at all, and maybe they don't even see the progress reports unless parents decide to share them. But they are nonetheless affected by the existence of this system. So they are tertiary stakeholders. The school administrators might be another stakeholder, but where they fall in this would differ based on how the school sets up the relationship. If they can use the tool to directly monitor and intervene in student progress, they might be primary stakeholders. If they just see aggregated progress reports so they can monitor things, they might be secondary stakeholders. If they never interact with the system in any way, they are nonetheless likely affected by the fact the system is there, and so they would be tertiary stakeholders. In designing these tools, we need to keep all three kinds of stakeholders in mind. For example, how does parents having more consistent access to great information affect the students? It might foster increased involvement by parents, but it might also facilitate helicopter parenting, where parents are too controlling over their kids' schoolwork and prevent them from developing the necessary metacognitive skills and self-discipline that they need to succeed later in life. User-centered design isn't just about catering to the user in the center of this diagram, but it's also about looking at the impact of our designs on all the stakeholders. You might actually come from a software engineering background, and so while user-centric design sounds obvious to some people, you might have experienced the other side of the coin. In many industries and domains, software engineers are still left to design user interfaces themselves. There is a fantastic book about this called The Inmates Are Running the Asylum by Alan Cooper, where he compares technology to a dancing bear at a circus. He notes that people marvel at the dancing bear, not because it's good at dancing, but because it dances at all. The same way people marvel at certain pieces of technology not because they work well, but because they work at all. The book was released in 2004, and since then the user has become more and more a focal point of design. And yet, there is still places where individuals with little HCI background are designing user interfaces for one reason or another. Since it's a stronger chance you have worked in a software engineering, reflect on that a bit. Have you seen places where software engineers, data scientists, or even non-technical people were put in charge of designing user interfaces? How did it go? Well, I know a guy who had a job as a user interface designer for a local broadcast company. He designed an interface, then he handed it over to a team of engineers for implementation. Late in the process, the requirements were changed a bit and new configuration screen was needed that the engineers just went ahead and looked up. He got the finished tool and it all worked beautifully and perfect, except for this configuration screen. It was a list of over 50 different settings, each with 3 to 5 radio buttons to the side. Each setting was a different length. Each radio button label was a different length. That was a kind of placed all over the campus. There was no grid. It was illegible. It was unusable, but it was technically functional. It met the requirements described in terms of what the user must be able to do, just not how usable it was. Fortunately, there's a greater appreciation of the value of user-centered design now than there was then. So many spaces have become so crowded that the user experience is what can really set a company apart. I have actually been noticing a trend lately toward new user experiences around really old tasks. I use an app called Stash to buy and sell small amounts of mutual funds. Buying mutual funds has been around forever, and E-Trade has even been doing that online for a long time. What differentiates Stash is the new user experience. Automated investing, simple tracking, simplified summaries, user experience design really has become a major differentiator between success and failure. Now, the user-centered design is all about integrating the user into every phase of the design lifecycle. So we need to know two things: what the design lifecycle is and how to integrate the user into each phase. Now, if you look up design lifecycles, you will find a lot of different ideas. We are going to discuss in terms of a four-phase design lifecycle that's pretty general and probably subsumes many of the other ones you will find. The first part of this is need finding. In need finding, we gather a comprehensive understanding of the task the users are trying to perform. That includes who the user is, what the context of the task is, why they are doing the task, and any other information related to what we are designing. Second, we develop multiple design alternatives. These are very early ideas on the different ways to approach the task. It's important to develop multiple alternatives to avoid getting stuck in one idea too soon. The third step is prototyping. We take the ideas with the most potential and we build them into prototypes that we can then actually put in front of a user. Early on, we might do this in very low fidelity ways, like with a paper and pencil, or even just verbally describing our ideas. But as we go on, we refine and improve. Fourth and most importantly, we perform user evaluation. We take our ideas that we prototype and we put them in front of actual users. We get their feedback, what they like and what they don't like, what works and what does not work, and then the cycle begins anew. The feedback we gain from the users as well as our experience with these prototypes and design alternatives improves our understanding of the problem. We now know new areas of the problem we might need to explore with some more need finding. Now, we might have some new ideas for design alternatives or some new ways of expanding the designs that we already have. We then take those things and use them to improve our prototypes, either prototyping new ideas that we didn't have before or making our prototypes more rigorous and more polished so that we can get even better evaluation. And then we put them in front of users again. Each time we go through this cycle, our understanding improves, our designs improve, and our prototypes improve. Eventually, our prototypes develop to the point of being designs ready for the launch. But the cycle doesn't end there. We keep iterating now with the live users doing the evaluation. Now at every stage of this design lifecycle, we are interested in gathering information from the user to better inform our design. To do that, we need a number of methods to actually obtain that information. Fortunately, there are a number of methods we can employ to try to gather the information we need. And in fact, the majority of this unit will go through all these different methods. These will become the tools in your toolbox. Things you can call upon to grab the information you need when you need it. Not the many of these methods are so well developed that you can cover them in the entire lecture videos or entire courses. For example, we'll spend about 2 to 3 minutes talking about naturalistic observation, and yet there are entire textbooks and courses on how to do naturalistic observation really well. The goal of this is to give you enough information to get started and enough to know what you need to explore next. Remember, one of the original goals of this class was not just to understand more HCI, but also to understand how big the field of HCI actually is. When we talk about feedback cycles, we talk about how they are ubiquitous across nearly every field, and the HCI itself isn't any different. In a feedback cycle, the user does something in the interface to accomplish some goal, and then judges based on the output from the interface whether the goal was accomplished. Then they repeat and continue. In HCI, we are brainstorming ideas and design interfaces to accomplish goals. And then based on the output of our evaluations, we judge whether or not the goals of the interface were actually accomplished. Then we repeat and continue. In many ways, we are doing the same things that our users do, trying to understand how to accomplish a task in an interface. Only in our case, our interface is the tools to build and evaluate interfaces, and our goal is to help them accomplish their goal. Now let's discuss about qualitative and quantitative data. There is one final distinction we need to understand going forward because it's going to come up at every stage of the design lifecycle: qualitative versus quantitative data. At every stage of the design lifecycle, we are interested in gathering data from users. Early on, that might be descriptions of what they do when they are interacting with the task, or it might be measures of how long certain tasks take to complete, or how many people judge a task to be difficult. Later on, though, it might be whether or not users prefer our new interfaces or how much better they perform on certain tasks. Now, data will always fall into one of two categories: qualitative and quantitative. Quantitative is probably the easier one to describe. Quantitative data describes anything numeric. When data is summarized numerically, we can perform statistical tests and summaries on it, draw formal conclusions, and make objective comparisons. Now, there are a lot of strengths of quantitative data, but those strengths come in large part because quantitative data only captures a narrower view of what we might be interested in examining. It's very strong for a very small class of things. Now, qualitative data covers pretty much everything else. Qualitative data covers descriptions, accounts, observations. It's often in natural language. It could be open-ended survey responses, or interview transcripts, or bug reports, or just your personal observations. Because of its flexibility, qualitative data gives us a much broader and more general picture of what we are examining. But the cost is that it's hard to generate formal conclusions conclusions based on qualitative data. Qualitative data may be more prone to biases. Now, in some circumstances, we can convert qualitative data into quantitative data. For example, we could count the number of surveys respondents to an end of course survey who mentioned course difficulty in their free response questions. Now, the free response question would be qualitative data, but numerically summarizing it generates quantitative data. Generally speaking, though, quantitative data and qualitative data serve different purposes in a design life cycle. I have heard it described quantitative data provides the what, the qualitative data provides the how or the why. When performing need finding or when doing some initial prototype evaluations, we are likely interested in users' qualitative descriptions of their tasks or their experiences with the interface. It's generally only after a few iterations that we start to be interested in quantitative analysis to find numerical improvements or changes. We can also use these in conjunction with one another, collecting both quantitative and qualitative data from the same participant. That's referred to as a mixed method approach. It's a mix of qualitative and quantitative data to paint a more complete picture of the results. Now let's do a quick exercise on quantitative versus qualitative data. Let's imagine we are doing end of course evaluations for some class. For each of the following types of data, note it down whether it would be considered qualitative or quantitative. We have responses to on a scale of 1 to 5, rate this course's difficulty, responses to how much time did you spend per week on this course, responses to what did you like about this course, count of students, the students mentioning office hours to the above questions, percentage of students that completed the survey, responses to a forum topic, requesting non-anonymous course reviews, the number of participants in a late semester office hour session, and the transcript of the conversation of the late semester office hour session. Now this is the answer to this question. Quantitative data is numeric. Any of these things that can be measured numerically really qualify as quantitative data. Many of these things are things that we can just count. We count the number of students, mentioning office hours. We count the number of participants. Here we basically count the number of students that completed the survey and divided by all the students in the class. And here we have them count how many hours per week they think they spent in the course. The first option can be a little bit tricky on a scale of 1 to 5 in a numeric scale, but because students have to choose 1, 2, 3, 4 or 5, it's not a continuous numeric scale. For example, we have no way of guaranteeing the student sees the difference between a 3 and a 4 as the same as the difference between a 4 and a 5. The types of analysis we can do on the first kind of data are more limited, but nonetheless, it still is measured numerical, so it still is quantitative data. Now, there are different types of quantitative data. Within the general category of quantitative data, there are different number of subdivisions. These are important because they inform what kind of conclusions we can generate and what kind of statistical test we can perform. We'll talk about evaluation, but it's important to understand what type of data you are gathering during all phases of the design life cycle. So first, there are four major distinctions in the quantitative data: nominal, ordinal, interval, and ratio data. Nominal data is also referred to as categorical data. It arises when we observe the number of instances of different categories. So for example, if we ask a bunch of users, how do you typically commute to work? These would each be different categories. Our data would be the number of people that fell into each category. Ordinal data is similar to nominal data, but there's some explicit ordering to those different categories. So for example, we might ask on a scale of 1 to 5, how would you rate your level of satisfaction with your commuting method? The user would choose highly dissatisfied, dissatisfied, neutral, and so on. These are still categories, but there is an ordering to them. But what's important here is that we don't actually know how big the gaps between these categories are. It could be that users perceive only a small difference between neutral and satisfied, or only a small difference between satisfied and highly satisfied. They might perceive the difference between satisfied and highly satisfied as smaller, for example, than the difference between dissatisfied and highly dissatisfied. That's where interval data comes in. With the interval data, we do know the exact difference between values. Imagine if we ask commuters, at what time do you leave for work in the morning? We know that the difference between 6 a.m. and 8 a.m. is the same as the difference between 8 a.m. and 10 a.m. So the interval between the different options is the same, but that can still lead to some strange comparisons. 8 a.m. isn't twice as late as 4 a.m. It's 4 hours later. But just because 8 is twice as much as 4, it doesn't mean 8 a.m. is twice as late as 4 a.m. We know the intervals between the numbers, but we don't know their ratio. We often talk about this in the context of temperature. 64 degrees isn't twice as warm as 32 degrees, even though 64 is twice 32. With the interval scales, there is no 0 point, only intervals between numbers. That brings us to the fourth kind of quantitative data, ratio data. Ratio data is just like interval data except it has a 0 point. So that means we can actually use ratios. If we ask our commuters how long it takes them to get to work, we know that someone who says 30 has twice as long as a commute as someone who says 15. And 15 is twice as long as 7.5, and so on. So these are our four general types of quantitative data. But there are more subcategories that come up among these two. For example, with nominal data, we can have single nominal and multi-nominal data. Our question here is, can a person being more than one category at the same time? Earlier, when we had this question, we phrase it as single nominal. We ask users to choose only one of these options. But it would be entirely possible to have users who take different forms of transportation on a regular basis. So why force them to choose only one? With nominal data, we might let them choose more than one option. So any given user can fall into multiple categories. If you read about quantitative data, you will see that ordinal data can also have multi-ordinal, but to be honest, I have never seen a compelling example of when that might happen. So I'm not going to show one here. With nominal data, we can have also binary and non-binary data. This distinction is a little bit more straightforward. The example we have already shown is non-binary. There's more than two different options. Binary nominal data has only two categories. This might seem like a silly distinction, but it's actually important because the type of statistical tests we do with binary data are a little bit different from the types of statistical tests we do with non-binary data. This distinction between binary and non-binary data can also apply to ordinal data. Non-binary ordinal data is pretty straightforward. It's a 1 to 5 scale or a 1 to 7 scale or anything like that. But we can still have ordinal binary data. For example, what grade did you earn in driver's test? We would interpret an implicit ordering between fail and pass, so that would make an ordinal data, but there's still only two options, so it's binary data. With both interval and ratio data, there's also a distinction between discrete and continuous. Discrete means countable, so if we ask how long is your average commute in minutes, we are generally expecting people to give an answer in a whole number. We are not expecting someone to say it takes 15.245 minutes. So that would be discrete. It's a countable number of minutes. If, on the other hand, we were to put sensors in people's cars and actually time how long their commutes are, we would arrive at continuous data. We would get values like it takes on average 31.2513 minutes for you to commute. And just like that distinction between binary and non-binary data, these distinctions sometimes informs the type of statistical test we are supposed to use. So these are general categories of quantitative data as well as some smaller distinctions that might be relevant. In practice, I can share that actually I find relatively few times in our work where we use interval data. When we are dealing with real numbers, we are dealing with numbers that have a 0 point like time or number of occurrences. Similarly, the type of statistical tests that we use for interval and ratio data are almost always the same. We similarly use some of the same tests for nominal and ordinal data. But I'm getting ahead of myself a little bit. For now, what's most important is just to understand what kind of data you are collecting. Just as there are different types of quantitative data, so also there are different types of qualitative data. In practice though, the types of qualitative data we generate are usually much more closely integrated with the way in which they are generated. For example, we could have discrete ratio data that comes from self-reported responses on a survey, or naturalistic observations in the wild, or logs from real interfaces. Qualitative data, on the other hand, tends to be determined more by how it's gathered. Some common types of qualitative data we'll deal with are transcripts from things like interviews and focus groups, field notes we might take during naturalistic or participant observation, artifacts like reviews left for existing interfaces or the existing interfaces themselves, and lots more. Quantitative data is numeric data and qualitative data is everything else. So the span of possible qualitative data is a lot larger. The qualitative data is strong because these types of data provide a much richer picture of what we are investigating. But with that strength comes some cost. Qualitative data is also more expensive to analyze and it's also a lot more prone to interpretation biases. So for that reason, we often convert qualitative data to quantitative data for the purpose of analysis. We do this through a process called coding. Now here, coding isn't writing Python code or doing anything like that. Coding is a process of taking free foreign qualitative data and boiling it down into some numeric categories. Typically, these categories are nominal, which allows us to do whatever kind of statistical test we can do on nominal quantitative data. During this process, we lose some of that rich data, but what we gain is a numeric representation that we can use in new ways. And plus, we didn't really lose that original data. It's just not part of the output of this coding process. So we can still go back and look at it if we need to. The other thing that comes out of this process is a documented methodology for actually coding the qualitative data to quantitative. So if anyone asks where we got those numbers, we can actually show them the process we went through. That helps us argue that our interpretations are not just biased interpretations of what happened, but they are actually rigorous analysis based on what qualitative data we have in our hand. In HCI, we almost always want to use some mix of these two. Our problems are far too rich to address with quantitative data alone, but for the same reason, we risk being dominated by biases if we focus solely on qualitative analysis. Now, as we go through this video in this course on methods, we are going to take a running example of the design challenge to explore the different HCI research methods. I am going to choose a challenge quite close to my profession, improving MOOC recording process, which we will deal with in later videos. Now, over the past several videos, you have been exploring how the design life cycle applies to the mini project of HCI that you chose to explore. Now that we have reached the end of this video, take a moment and reflect on the life cycle that you have developed. How feasible would it be to actually execute what would you need? What users do you need? How many? When do you need them? There are right answers here, of course. Ideally, you will need users early and often. That's what user-centered design is all about. In educational technology, that might mean having some teachers and students and parents that you can contact frequently. In computer-supported cooperative work, that might mean having a community you can visit often to see the new development. In ubiquitous computing, that might mean going as far as having someone who specializes in low-fidelity 3D prototypes to quickly spin up new ideas for testing. Now that you understand the various phases of the design lifecycle, take a moment and reflect on how you use them iteratively and as a whole in your chosen area of HCI. To conclude this video, we introduce the concept of the design lifecycle. There are lots of versions of the design lifecycle out there, but we are going to focus on the most general 4-step cycle. The cycle starts with need finding, then goes to constructing design alternatives, and to prototyping, and then the user evaluation, and then the cycle repeats. The goal of this cycle is to realize user-centered design. Design that takes into consideration the user's need at every step. In the subsequent videos, I am going to focus on filling up your design lifecycle toolbox with tools for gathering the right kind of data at the right time and using it in the right way. So we have reached to the end of this video. If you have any questions related to this topic, then you can ask them in the comment section, or you can put it on Google Classroom, or wait for our next live session so we can discuss it in an interactive manner. Thank you.